All right, hello everybody. What we're doing today is we're looking at a review of solving quadratic equations. So far we have three methods. We'll start with method one, solve by factoring. We did this way back when we were together in class in person using the zero product property. And then we used square roots. We spent a lot of time simplifying radicals, and then we solved quadratic equations by taking the square root of each side of the equation. So we'll review that. And then method three, the one we've been working on most recently, solving by completing the square. So in that method, our goal is to force this to be a perfect square trinomial so that we can take the square root of both sides of that equation and solve. And then we'll kind of hint at a fourth method that we'll cover next week. So I'd like to start with method one here, solve by factoring. And again, this is already in standard form equal to 0, which is my first goal. Secondly, we'll factor it. And let's see, my first term is 2x squared, so I know I'm probably going to have a 2x times x. And then the only factors of 3 are 3 times 1, and I think it might work out this way. 3 times 1, let's see, I want a minus 3 plus 1, so that if I FOIL this out, I get 2x squared plus 2x minus 3x. Okay, so that would be a negative 1x, and then negative 3 times 1 is negative 3. Okay, we have factored it. Now that we've factored it, we have one factor multiplied by a second factor to get a result of 0. Therefore, the only way to multiply two factors together to get an answer of 0 is if one of them is 0. So we take and we set each factor equal to 0. Either 2x minus 3 could be equal to 0, or x plus 1 could be equal to 0. Now we just have two basic equations to solve. Add 3 to both sides, and we would have 2x is equal to 3. Divide both sides by 2. X is equal to 3 halves, or 1.5. I prefer just to write 3 halves. Subtract 1 from each side over here, and we get x is equal to negative 1. Now, if the directions on your quiz say solve by factoring, you are getting points for factoring correctly, setting each factor equal to 0, and solving. Sometimes for 2 answers, sometimes for 1 answer. And if it's not factorable, then you wouldn't have, maybe you wouldn't be factoring. So that's what I'm looking for. I'm giving you points for showing that work. Method 2, solve using square roots. I think everyone would agree this is kind of the easy one. Basically, I want to get my x squared by itself. So we're just adding 20 to both sides. It will get x squared is equal to 20. Now get x by itself. Our action step here, take the square root of both sides. We get x alone is equal to, don't forget the plus or minus, the square root of 20. Also, I expect this answer to be completely simplified. X is equal to plus or minus. You're going to break 20 up into the square root of 4 times the square root of 5. The square root of 4 is just the number 2. X is plus or minus 2 times the square root of 5. So if I ask you to solve a quadratic equation using square roots, you're going to find something squared by itself, like we found x squared by itself, and just take the square root of both sides. Again, you have two answers here. A positive 2 square root 5 or a negative 2 square root 5. Okay, moving on. Method 3, solve by completing the square. We have x squared plus 11x equals 12. Mainly, I want everything on the left side of this equation to factor into a perfect square. Our goal is going to be to take the square root of both sides. For that to be true, we have to add something to both sides of this equation. And the biggest key you're going to look for is the b term. Half of 11 is 11 halves. Whatever 11 halves squared is what we're looking for here. So I'm going to add half of b squared to both sides of the equation. 11 halves squared. Now on the left side here, I'm just going to write x squared plus 11x plus 11 halves squared is equal to 12 plus, well, 11 halves squared, that's just 121 fourths. Okay, now this left side of the equation, it is a perfect square trinomial. We can factor this. This factors as x plus 11 over 2 squared. If you want to FOIL this out to prove it works, that's fine. I do not need you to do that. But if you want to prove to yourself that this is a correct factoring, you may check your work there. Okay. I'm going to want to combine these, so we'll need a common denominator. We'll call it 12 over 1. Common denominator 4. So what we'll have here is 4 times 12, or 48 fourths, plus 121 fourths. And maybe we'll just show one extra line of work here. X plus 11 over 2 squared is equal to 48 fourths plus 121 fourths, 169 fourths. Now, I'm ready to take the square root of both sides. Take the square root of both sides of the equation, and we just get x plus 11 over 2 is equal to, oh, I can use my quotient rule. The square root of 169, that's just 13, over the square root of 4 is just 2. And again, I'm not going to forget my plus or minus. Now all we have to do is get x by itself. Subtract. And maybe since this is a plus or minus, maybe at this point I would break it into two parts. I would know that, well, x plus 11 over 2 could be equal to a positive 13 over 2. Or x plus 11 halves could be equal to a negative 13 over 2. Now in either case, I just have to subtract 11 halves from each side. X equals, now I have 13 halves minus 11 halves is just 2 halves, or just the number 1. X could be equal to 1. Or minus 11 over 2 minus 11 over 2. X could be equal to negative 13 minus 11 more, that's negative 24 halves, which simplifies to x equals negative 12. So I have two answers in this case. Positive 1 and negative 12. So in review here, when we complete the square, we basically are just, our goal is to be able to take the square root of both sides. In order to do that, we have to force this to be a perfect square trinomial. This c term is always half of b, or half of the linear term, squared. That will always work. Okay. All right, have a great day, folks. Good luck on your quiz.